Hind student, today we are going to start our next unit of telemetry principle, that is multiplex system. In the previous lecture we understand about the various telemetry principle, the definition, classification of telemetry principles with some example such as PLCC. We also understand the block diagram of basic telemetry systems. The first part of that telemetry principle was related to the classification, whether the next unit, second unit is related with the multiplex system. So, basically what is multiplexing? Our first question regarding this unit or first question regarding this multiplex system is, this is related to the syllabus. Basically, when we are talking about the multiplex system, we are going to here consider about two main things. That things are multiplexing and modulation, because combinedly this multiplexing and modulation is going to made a multiplex system. As your syllabus says, in this unit you are going to understand frequency division multiplexing systems such as FDM, then FM circuits, phase modulation circuits, receiver. Similarly, the time division multiplex system, TDM and PCM related things. Then this is the very first example. What you can see in this particular diagram, you can see here we are using a multiplex system of PTSN system with using optical fiber multiplexers. What is going to be happen here? Here this is the transmitter side, this is the receiver side, and the distance between transmitter and receiver is up to 100 kilometers with single mode of optical fiber. Now, at the transmitter side we have a transmitting block with the various type of signals here. Similarly, at the receiving side we have a receiving block with the various receiving stations. What is going to happen actually here? You can see easily that here we are getting some signals, we are combining them, performing the modulation and placing the all signals, or these all signals are going to use a single channel. It means at the same time for the transmission of telemetry signals we are using modulation with the multiplexing. So, this is about the basic multiplexing multiplex system example. Now, we are going to understand one by one both the things. First one is what is multiplexing, then we are going to concentrate on modulation. Actually, as you all know that there are two kinds of signal, first one is analog signal and second one is digital signal. If we are going to use a analog signal for the transmission, we are always using analog multiplexing technique and analog modulation techniques for the multiplex system. Similarly, for the digital we are going to use digital multiplexing technique with the digital modulation scheme. As you all know that various kind of analog modulation schemes are such as amplitude modulation, phase modulation, frequency modulation. Whether the analog multiplexing techniques are FDM, that is frequency division multiplexing. So, the question arises here that what is multiplexing? As you are going to take an example of that starting of the telecommunication time, at the remote location or in the one city they are using number of telephone users and that all users are connected with the other city also. But between two cities there is only a one line for the transmission, and that one transmission line is going to be used by the both side of the users. So, basically here a question arises that actually they are accessing the main line or they are using multiplexing line. Actually there are two kinds of technique. One is multiple access and second one is multiplexing. You have to differentiate between these both techniques actually, because in multiplexing what is going to be happen, you have n number of users and out of n numbers only one user is using that particular line for the transmission and all other users are became idle at that time. But in the multiple access the same line is going to be used by the all users on all time. So, basically in multiplexing or in the simple word you can say that multiplexing is many input to one output. So, under the simplest condition a medium can carry only one signal at any moment in time. Then if we try to pass these multiple signal through a common medium, they will possibly interfere with each other. Then when two or more signals with same frequency pass at the same time through a common medium, the interference phenomenon occur. So, basically what is going to be happen? We have to design such kind of arrangement which is going to use that channel for only single user, that is our main requirement. So, this is the typical diagrammatical example of multiplexing and no multiplexing. If this is the side of transmitter and this side of the receiver, there are 4 users, also there are 4 users. If we are not applying the multiplexing, what is going to be happen? Each user is connected with the another user with a individual line, and if the number of users are increasing continuously, it means that will create a very messy structure. So, to avoid that particular messy culture, actually multiplexing is going to be done. So, that multiplexer is basically a unit which is controlled by some kind of select signals, and that select signal in the particular digital part or the particular arrangement, this multiplexer is going to use this channel or path for these all 1, 2, 3, 4 users. Means you have a single channel going to be divided into 4 1, 2, 3, 4 users. So, you can see here there are n number of users and you are getting one user at output. So, also it is n to 1. At the receiver side, the reverse phenomenon is going to be happen, that demultiplexing. Now, here input is 1 and that is going to be selected on the desired user part or the desired user channel. So, basically this is showing the multiplexing versus the no multiplexing. So, this is the basic introduction that we have to devise a way to avoid the interference of the signals. For this, when what is going to happen, multiple signals should have different frequency, they must not travel at the same time and must not travel through the same medium. So, for multiple signal to share a medium, the medium must somehow be divided so that each signal receive a portion of the total bandwidth. So, what we are going to perform in this particular multiplexing part, we are actually going to divide the channel or the particular medium to the various users on particular basis, or we are going to allot a particular portion of the total available channel bandwidth to a particular user. So, this is multiplexing basic introduction. Now, if we talking about the technical definition, then it is the set of technique that allow the simultaneous transmission of multiple signals across a single data link line. As I told you, here this is the transmitter, receiver, where n number of user, and between them there are multiplexer and demultiplexer with a single channel. Means this single channel or single path is having transmission of multiple signals on a single data link. So, in multiplexing is done using a device that is called multiplexer. I already told you that multiplexer is going to combine n input lines to generate one output line, that is called many to one, n to 1. Similarly, at the receiver side, a device called demultiplexer, which is actually separate signal into its component signal, one input and several outputs. So, one to many, many to one, one to many. Now, these are the types. When we are talking about a signal, actually any signal is having three basic parameters: amplitude, frequency and phase. Or when we are talking about a channel, that basically channel having two things: frequency and time. Just for example, I am having 4 users, each users want a separate line, but actually we having a channel, that channel having the 400 megahertz bandwidth, and we are going to use this 400 megahertz for 4 users. So, what are the possible solutions? Either I am going to divide this 400 megahertz to these 4 users by simply allocating 100 megahertz to each user, or I am going to allot the particular 400 megahertz to a single user for a single time. It means there is a possibility by which we can divide that particular single channel between transmitter and receiver on the basis of two things, either that is frequency or time. So, as per that dividation, multiplexing are basically of two types. These are the basic classification of multiplexing. Rather than other than this frequency division multiplexing and time division multiplexing, wavelength division multiplexing, space division multiplexing are also possible. But these WDM, SDM are used for the specific purposes, but the most basic classification of multiplexing is FDM and TDM. Time division multiplexing is again divided into two parts. First one is synchronous and second one is asynchronous. So, actually when we are talking about these both dividation, what is going to be happen in frequency division multiplexing? If we are having 400 megahertz with 4 users, we are simply dividing this 400 megahertz to each user by dividing it into 100 megahertz to each user. But when we are talking about frequency division multiplexing, what we are going to do? We are going to create a slot of 1 second, that is a time slot. That time slot is of 400 megahertz complete bandwidth. Out of that time, 1.4 second is allotted to user 1. Similarly, next 1 by 1/4 second is allotted to user 2, next is for 3 and 4. It means 1 second is divided to 4 users by allocating 1/4 second 400 megahertz completely to the single user. So, in the both arrangement you can see that in FDM a user can transmit data continuously, but in time division multiplexing a user will wait for its slot. When the next slot is coming, then he is going to then it is going to transfer the data on that particular slot and using the complete 400 megahertz bandwidth. It means in FDM particular bandwidth is limited for a user, but in time division bandwidth requirement is increased, bandwidth allocation is increased, but the time for which allocated is less. In the particular part you understand one thing, that you are equally dividing the time slot to all users as 1, 2, 3, 4. So, when we are allocating equal time to all users, that is called synchronous transmission or synchronous time division multiplexing. But when we are delivering when we are dividing this time slot to various users not in a uniform manner, then that particular type of time division multiplexing is called asynchronous time division multiplexing. So, starting with the multiplexing need, as you all understand that in the multiplexing why it is required. Actually, in multiplexing transmission services are very expensive, lease line packet switch network, and if we are going to apply various transmission services for the single line or for the single system, it means the cost is going to be increased very much. Second point is multiplexing and compression techniques save the business money, then that is also related to the cost cutting part of the particular requirement. And also for a company the data capacity of line is also increased when we are using the time division multiplexing, and the most data service requires modest data rate support in the case of that particular multiplexing schemes. So, in this particular part you can easily understand one thing, that when we are talking about the multiplex system, that multiplex system is actually the combination of multiplexing and modulation. In multiplexing and modulation, actually what we are going to do, we are going to do some basic things, such as in multiplexing we are either using FDM frequency division multiplexing or time division multiplexing. As you can understand, in FDM we are allocating the particular line we are allocating the particular line by dividing it to the various users in the form of frequency bandwidth that is used for the analog transmission. In the time division multiplexing, what we are doing? We are giving a slot, we are giving a time slot for the transmission and allocating the complete bandwidth to that particular user for that complete time. So, these multiplexing technique are going to help you to design the multiplex system for a individual telemetry system. If your telemetry system is using analog signal to be transferred, then we are going to use FDM, and as we are going to use frequency division, that is why for the modulation purpose we are going to use frequency modulation. It means for the analog telemetry system we are going to use a FDM FM multiplexed system. Whether when we are talking about the digital part or the digital signal, we are going to use time division multiplexing with either pulse amplitude modulation or pulse code modulation. So, this is basically giving you the complete system or complete picturization of the particular multiplex system part, that either you are going to transmit the analog data or you are going to transfer the digital data. In the next unit or in the next part, we are going to concentrate on the types of frequency division multiplexing and the time division multiplexing. With the frequency modulation frequency modulation and the digital modulation techniques. So, to understand all these things, it is required that you should go through the various multiplexing techniques, and these all multiplexing techniques are basically going to help you to design the telemetry system. As you know that, or I can take an example that sometimes in particular remote areas in which geographical conditions has to be monitored for the weather changes or some other kind of condition, or you can take the example of that particular mishappening that was occurred in the Kedarnath. You understand one point, that in Kedarnath there was a glacier and that glacier was broke down due to the heavy rainfall in that particular region. What was happening at that time? The particular institute, that was Wadia Institute, that was using some kind of sensor placed at the glacier of the Kedarnath, and that particular sensors are taking the data, and that data is directly collected at the particular sensing station which is located at the Kedarnath glacier. But if we are able to use that telemetry system design, then we can easily understand, or we can take the real time data from that place to the next nearest station or the disaster response center. So, to design these kind of particular system, it is required that we should manage, or we should make some kind of specific arrangement, so that we can arrange all the arrangements. So, for this complete telemetry system, we required these kind of multiplex system, and these multiplex system we are going to discuss in the next lecture. So, till then, thank you.